Hi everyone, so welcome back. So we're going to continue the third part of solving quadratic equation by taking the square root. Okay, so I want to go over the steps one more time. So, okay, what is the first step? So step one, isolate the term with the x squared or the expression being squared. Okay. Step two, take the square root on both sides. This why the reason why you take the square root on both sides is to undo the square. Okay, and then step three, if applicable, we are going to rationalize the denominator. For this example number, for this example that I'm going to do now in this video, you're going to be rationalizing the denominator, and I will explain you what it means. Okay, in a couple minutes. So, and then step four, you're going to solve for the variable, and here the variable is x. So let's follow the step. Step one, you're going to isolate the term with the square. Okay, so let me rewrite the expression below. So you're given 3x squared minus 2 equal to 0. So what do I have to do? You're going to isolate the term with the square. Here the term with the square is x squared. Let me highlight that. So to isolate the term with the square, I need first to add 2 on both sides. Okay, and after adding 2, the new equation will be 3x squared equal to 2. Okay, so after adding 2 on both sides to undo minus 2, I need to divide by 3. To undo multiplication of 3, I divide by 3 on both sides, and the new equation is going to be x squared equal to positive 2/3. Okay, that is how we are isolate the term of the square x squared here. Now we need to undo the square. Okay, to undo the square, you're going now to take the square root on both sides. So you're going to take the square root on both sides. So when you take the square root on both sides, the square root on the right, make sure you include the symbol, the sign, the minus, and the plus. Okay? And then because it's only true for even roots, there are always going to be two answers, one positive and one negative. So the new equation is going to be then x. Again, the square root undo the square. They undo each other. We call them inverse operation, okay, or inverse function. So you end up with x equal, I have negative plus sign, the square root of 2 over the square root of 3, okay? Now, for this example, for example number 9, we have to rationalize the denominator. Why? So 3 is not, like one of my students call it, is an imperfect square, okay? So the square root of 3 cannot simplify to rational number, okay? So I need to fix it, okay? So in algebra, we cannot have a square root in the denominator, okay? So that's what you have to mean, you have to rationalize. You need to have a rational number, a whole number in the denominator. So then what do we do? So what do you want to do to rationalize the denominator? You're going to highlight, okay, you're going to take the denominator, which is square root of 3. You're going to multiply by square root of 3 and divide by square root of 3. Remember, you take a number and divide it by itself, it's just 1. Okay, this expression, square root of 3 divided by square root of 3 is simplified to 1. By the reason, so I'm not changing the expression here, square root of 2 over square root of 3. So all I'm doing is rewriting it in a way that in the denominator, you only have whole number, like no square roots. You only have rational number, no irrational number. Okay? So now this one continues. Then you end up with x is equal to positive negative. So now square root of 2 times square root of 3 multiplied to square root of 6 over square root of 3 times square root of 3 is square root of 9, and square root of 9 simplified to 3. Okay. Okay. So let me not do that. So let me use a bracket. So you have two answers. Okay. The first one is, I'm going to start with negative value. It's negative square root of 6 over 3, comma, and positive square root of 6 over 3. So you have two solutions. So now, alert, alert, alert. Do not go ahead and say, 3 goes into 6 twice. So it's going to be negative square root of 2. No, 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 no. It doesn't work, okay? So because they're two different kind of number, one is irrational, one is irrational and the other is rational. So do not simplify them, okay, because they're not the same kind of numbers. So you leave them alone, okay? So now let me check your understanding with number 10. Okay, for number 10, I want you to solve this quadratic equation by taking the square root. It's 2x squared, okay, minus 5 equal to 0. And again, let me go back to number 9. So how do we call this kind of solutions? I forgot to point out to you in the last video. So because you can see the square root, okay, we have for the type of solution you have here two what? Irrational or rational? Because you can see the square root, we call it two irrational solutions. Okay, so now let's do number 10. Please pause the video and try to do number 10 by yourself. Okay, so my answer was the two solutions are negative square root of 10 over 2 and positive square root of 10 over 2. Okay, again, do not simplify. So 2 goes into 10 5 times. The square is negative square root of 5 and positive square root of 5. No. It doesn't work this way. And the reason is because you have two different kind of numbers. So one is irrational, the other one is on the denominator is rational. So leave them alone. Okay. So then let's see here. So I follow the steps again. I isolate the term with the squared, x squared here. I get x equal 5 over 2. Step 2, I took the square root on both sides, and I end up with x equal positive and negative square root of 5 over square root of 2. And then I rationalize the denominator by multiplying by square root of 2 and divided by square root of 2. And I end up with positive and negative square root of 10 over 2. And the solution are two irrational solutions. Why? Because you can see the square roots. So this quadratic equation has two x-intercepts, and those x-intercepts are two irrational solutions. Okay, so that's it. Thank you for watching my videos. Okay, I'm going to do another video where you're going to have a set of complex conjugates. Okay, all the solution will be complex numbers. Okay, since they're complex numbers, they call them complex conjugates in the next video. Okay, so this is it for this video. Thank you for watching my video. Have a wonderful day and see you in the next one. Bye bye.